Welcome student. Today we will start our next module of our curriculum, that is the process management, and this is the chapter Introduction to Process. I am Devashri Mitra, Assistant Professor of CS Department from JIS College of Engineering. So this is the outline of the class. First we will learn what is process, then we will learn process versus program, then characteristics of process, process state, process control block, context switch and process queues. So now what is process? So assume in our computer there are many programs executing. Assume you are executing an addition program, or you are executing a browser program, or you are executing a movie, or you are executing a song, anything. Whatever the program are executing in your computer, so for this each program there are certain situation or there are certain instance when this program will have some active condition. That means it will actually getting attention the CPU. So a process is basically a program in execution. The execution of a process must progress in a sequential fashion. A process is defined as an entity which represents the basic unit of work to be implemented in the system. To put it in a simple terms, we write our computer program in a text file, and when we execute this program, it becomes a process which performs all the tasks mentioned in the program. So when a program is loaded onto the memory, it becomes a process. It can be divided into 4 sections: stack, heap, text and data. Just see the following diagram. In this diagram there is a portion that is a stack. This is heap, this is data, and this is text. So this is the logical representation of any process in our computer memory. So what is process? A program is in execution is called process. So now we will learn what are the basic difference between program and process. So usually a program is a set of instruction. From our first semester we have learned that a program is a set of instruction, whereas a process is a program is in active state, or a program is in execution. Next one is program is a passive entity, but the process is active entity. Lifespan of program is longer, but the lifespan of process is limited. Program is stored in disk in some file and does not require any other resources, but process holds such as CPU, memory address, disk, IO, etc. So these are the basic difference between program and process. So most important point you have to remember, a program is a passive entity, but a process is an active entity. So these are the characteristics of a process. So what are the characteristics a process will have? A process must have process ID. A process will have some state. A process can occupy some CPU registers. There should be some account information, IO status information, CPU scheduling information. These are the information, or these are the characteristics a process will have. So what is process ID? A process ID is a unique identifier assigned by the operating system. So assume our operating system having the process ID 0. Maybe whatever the program you are executing in your computer, each and every programmer, whenever this will become process, our computer will recognize a process by its ID. Okay, so this ID is called process ID. Next is the process state. So a process can be either ready, running, or idle, or waiting. Similarly, CPU registers, like the program counter, CPU register must be saved and restored when process is swapped in and out of CPU. Account information, next is the IO status information. What are the status of different IO related process? Next is the CPU scheduling information. For example, prioritized or any other job scheduling algorithm where you have to find out some data. These are the things. Okay. So this is the process state. So each and every process will have some states. So it's new, ready, running, waiting, and terminated. So start, this is the initial state when process is first started or created. Ready, the process is waiting to be assigned to a processor. Ready processes are waiting to have the processor allocated to them by the operating system so that they can run. Process may come into the state after. Next is the start. Start is the state or while running it but interrupted by the scheduling to assign CPU to some other process. Next is the running. Once the process has been assigned to a processor by the OS scheduler, the process state is set to running and processor execute its instruction. Next is the waiting. Process move into waiting state if it needs to wait for resources such as waiting for the user input or waiting for file to become available. Next is the terminated or exit. When the process finishes its execution or it is terminated by the operating system, it is moved to the terminated state where it waits to be removed from main memory. So I am explaining this diagram. So whenever a process is created, it will enter to the new state. So whenever new state is the process, is the symbol of process creation or some process entered into the system. Next is the, after getting the admitted into the system, a process will be in a ready state. So ready state is nothing but a waiting condition where it is getting ready to be executed. Next is, from this ready state it will go to the running state. So running state means it is actually getting the attention of CPU. Next is the, from this running state a process can move to waiting state. Assume a process is executing but there are some IO related operation must be executed. Assume a process is executing but sometimes you need to take a print from a printing device or any IO related operation you need to perform. So then this process will go to the waiting state and you are taking the printing, and after taking the printing, IO event completion. This is the IO event completion. After IO event completion, it will again go into the ready queue. From the ready queue again scheduler dispatch will occur and it will again go to the running state. Similarly, if whenever a process is executing but there are some interrupt will occur. Interrupt means forcibly a process had to remove from running to ready state. Okay, so this is interrupt, and whenever process complete its execution, there is nothing pending to do, so it will go to the terminated state and exit from the system. So this is the process state, and just remember this diagram. This diagram is very, very important. Okay, so next is the process control box. So process control box is nothing but a data structure which will mainly hold the related information of process, just like process state, program counter, CPU register, CPU scheduling information, accounting and business information, memory management information, and IO status information. So process state means it will hold the information, either a process can be in new, ready, running, waiting, this kind of state. Program counter means the program counter lets you know the address of the next instruction, that is the what are the next instruction to be executed, this address to be stored in the program counter. Next is the CPU register. We all know CPU register is the very first memory. Among all the memory, CPU register are the fastest memory. So the component include accumulators, index, general purpose register, and information of condition code. Next is CPU scheduling information. This component includes a process priority, pointer for scheduling queues, various other scheduling parameters, Accounting and business information, it includes the amount of CPU and time utilities like real-time use, job or process numbers, etc. Next is the memory management information. This information includes the value of base register, limit register, page or segment table. This type of value it will hold. Next is the IO status information. This block includes a list of open files in the list of IO device that are allocated to the process, etc. So next one is the context switch. What is context switch? Assume our CPU is giving the attention to process 1. Suddenly there will be some situation will occur, CPU will move to the process 2. So CPU will give attention to the process 2. So switching between process 1 to process 2 is called context switch. So what is context switching? A context switch is the mechanism to store and restore the state or the context of a CPU in process control box so that a process execution can be resumed from the same point at a later time. Using this technique, a context switch enables multiple processes to share a single CPU. Context switching is an essential part of a multitasking operating system features. When scheduler switches the CPU from executing from one process to another, the state from the current running process is stored into the process control box. After this, the state of the process to run is loaded from its own PCB and used to set program counter, register, etc. At that point, the second process can start executing. When the process is switched, the following information is stored for later use: the program counter, scheduling information, base and limit register value, currently used register, change state, IO state information, accounting information. So these are the important points you have to remember regarding context switch. So next is the process queue. What are the process queue? So whenever a process is submitted into the system, the process must be first submitted to the job queue. From the job queue, it will come to the ready queue. After ready queue, whenever CPU scheduler fetches from ready queue to the running, it is in running state. Next is the waiting queue. Okay, so this type of three types of queue mainly used in process life cycle state. So what is job queue? In starting, all process gets stored in job queue. It is maintained in secondary memory. So job queue is where in your computer hard disk or in the secondary memory job queue is stored. Okay, so in starting, all the process gets stored in the job queue. It is maintained in the secondary memory. The long-term scheduler peaks. So long-term scheduler peaks from job queue to ready queue. Okay, now is the ready queue. Ready queue is maintained in primary memory. So remember, job queue will be in your computer hard drive and ready queue will be in your computer memory. So between job queue and ready queue, there is a scheduler that is called the long-term scheduler. From the ready queue and the CPU, there is another scheduler that is called the CPU scheduler or the short-term scheduler, and short-term scheduler are very fast. So ready queue is maintained in primary memory. The short-term scheduler picks the job from ready queue and dispatched to the CPU for execution. Next is the waiting queue. When the process needs some IO operation in order to complete its execution, operating system changes the state of the process from running to waiting. The next PCB associated with the process gets stored on the waiting queue, which will be used by the processor when the process finishes the IO. Okay, so these are the summary. I will again repeat some important point regarding this chapter. A process is defined as the execution of a program that performs the action specified in the program. Process management involves various tasks like creation, scheduling, termination of process, and deadlock. The important element of process are stack, heap, data, and text. Next is the PCB is a full form of process control box. It is a data structure that is maintained by the operating system for every process. A process state is a condition of the process at a specific instant of a time. Every process is represented in the operating system by a process control box, which is also called task control block. So these are the important books for your course. These are the important questions for your semester exam. Draw and explain state transition diagram of a process in every exam or semester exam. This is very important. This question will carry 5 marks. Next is write down short note on context switching, process control box. What are the difference between program versus process? Explain different process queues. These are the important questions for your semester exam. Thank you.